Have you ever watched a drone zip through the sky and wondered, how does that thing actually work? It seems to defy gravity, but the secret isn't magic. It's pure, elegant physics. Today we're going to break down exactly how these amazing machines, specifically quadcopters, take to the air and perform those incredible maneuvers. Drones, or UAVs, are everywhere these days. From delivering packages and surveying farms to capturing breathtaking movie shots. The most common type you'll see is the quadcopter, with its 4 distinct propellers. So, how do they get off the ground? It all comes down to a principle you probably learned in school, Newton's third law of motion. For every action, there is an equal and opposite reaction. The drone's propellers are designed to push air downwards. This downward action creates an equal and opposite reaction, an upward force called lift. When this lift becomes greater than the drone's own weight, it takes off and climbs into the air. To hover perfectly still, the lift and the drone's weight have to be in perfect balance. But wait, if you just have 4 propellers spinning, wouldn't the drone just spin wildly out of control? This is where the genius of quadcopter design comes in. Look closely, and you'll see that 2 of the propellers spin in one direction, say clockwise, while the other 2 spin counterclockwise. The twisting force, or torque, generated by the clockwise propellers is perfectly canceled out by the torque from the counterclockwise ones. This beautiful balance is what allows the drone to remain stable and not spin like a top. Okay, so we know how it hovers. But how does it move around? This is controlled through 3 main movements: pitch, roll, and yaw. Pitch is the drone's forward and backward tilt. Roll is its side-to-side tilt, and yaw is its rotation, or which way it's facing. Let's say you want the drone to fly forward. The onboard controller will slightly decrease the speed of the front 2 propellers and increase the speed of the back 2. This causes the drone to tilt forward. That's the pitch. Now, with the propellers tilted, a portion of their powerful lift is directed backward, pushing the drone forward. To move backward, it does the exact opposite. To move sideways, it uses roll, speeding up the propellers on one side and slowing them on the other, causing it to tilt and slide left or right. What about turning to face a new direction? That's where yaw comes in, and it's all about manipulating that torque we talked about earlier. To turn, or yaw, to the right, the drone will slightly speed up the propellers that are spinning clockwise and slow down the ones spinning counterclockwise. This creates a net torque imbalance, causing the entire drone to rotate to the right. To turn left, it does the reverse. It's an incredibly precise dance of propeller speeds that allows the pilot to aim the drone exactly where they want it to go. So, from takeoff to intricate aerial acrobatics, everything a quadcopter does is a direct application of fundamental physics. By simply varying the speed of its 4 propellers, a drone can generate lift, cancel out unwanted rotation, and steer itself in any direction. It's a masterful blend of engineering and classical mechanics. The next time you see a drone flying, you'll know it's not just a cool gadget, but a real-life physics lesson in action. Thanks for watching. If you enjoyed this breakdown and want to learn more about the tech that shapes our world, make sure to hit that like button and subscribe for more videos. Fly safe, and see you in the next one.